Okay, back to the equipment. One of the features of the MonCvONE is its ability to test the entire visual field. Here on this drawing, you see the limits of the Humphrey in red color. The Humphrey doesn't test the entire visual field. It's limited to 40 degrees up, something like, I think, 60 degrees down, whereas the MonCvONE reaches the limit, up to 105 degrees on the temporal side, up to 60 degrees up. So that's a true limit in most of the normal subjects. Another feature, because we can do ultra-wide field perimetry, it's to be able to compare it with the modern technology used to do imaging. So we have ultra-wide field imaging available. We have perimetry, but how can we compare them? And actually, I won't go into details, but the problem is going from the sphere of the retina, hemisphere, if you want, and project it on a plane like it is for perimetry or like it is for imaging. The problem is that we have different modes, different scales. And we have developed some software to allow us to import images from ultra-wide field imaging system and put it on the back of the perimetry, changing the scale. You know, the ultra-wide field imaging uses what is called stereographic projection, whereas Goldman perimetry is quite different. So we have developed tools to allow us to do this. And you can do it in two different ways. You can do it before the exam and run your exam, your perimetry exam, on top of the iFundus image, or you can do it after the exam and make a comparison after the test. Both things are possible. And this is showing some examples. We have on the left down side an example with the patient who received laser treatment, and you see the laser spot and the well superposition of the perimetry which was obtained later. You have retinitis pigmentosa cases. Well, and this I think was a patient who had a paintball accident. And those traces come from Dr. Zanlonghi in France, Nantes. As I mentioned before, we like to get a response from the rods and the cones. And as you know, there are quite a number of ways to differentiate the rods from the cones. One of the possibility, of course, is to play with light level. And working under Scotopic or mesopic or photopic levels is something which is possible on the MonCvONE. So actually, Scotopic testing is becoming more and more a possibility for the early detection of eventually macular degeneration or retinitis pigmentosa. And also it might have some applications for driving tests or low vision tests. So standard parameters, as you know, operate under the photopic range. You cannot go down below the background level of 10 candela per square meter. The only, I think, as far as I know, the measurement parameter, scotoperimeter, that allows you to do scotopic perimetry. But it can only do this kind of test, whereas the MonCvONE-CR, you can operate it under scotopic or different levels of mesopic or different level of photopic levels. So it's a very flexible system, and that's possible because of the LED technology. In addition to this, we can generate color stimulation. We can generate different background levels with different colors, and also the stimulus can be, of course, white with different sizes, the classic different size of Goldman. Also, we can use user-defined dichroic filters, up to 5 different filters, and as we will see later, we have a number of studies using this kind of solution. So one of the first tests used in clinical trials nowadays is the FST, which stands for Full Field Stimulus Threshold Test. It's a very simple test. After dark adaptation, then we measure the threshold of sensitivity to a global flash of light for two colors, for the blue and for the red. And this was a technique introduced first by an engineer at Shea Eye Hospital. And he demonstrated that you can evaluate the contribution of cones because with the type of red light they are using, the response to blue and to red, it's not exactly red, but whatever. It's would be similar response for the cones where there will be a huge difference between the blue and the red for the rods. And this allows you to quantify the response of rods and cones. Although on the MonCvONE-CR, we have implemented this test. You can do it with each color separately, or you can do it by combining in sequence the different colors. And after dark adaptation, which may take some time, it takes only 2 minutes to measure the threshold on the subject. But this test has some limitations. It has some advantages. One advantage is that it is less dependent on fixation, so that's suitable for patients with nystagmus. Another advantage is relatively fast. The disadvantage is that you don't have any information about the localization. If you have an improvement or an increase of severity, you don't know where it's taking place. And the lessons we had from chloroquine intoxication tell us that it's important at the early stage of many diseases to be able to pick up some local information, which is not possible with the FST. So then we have this other technique, which was introduced a long time ago by Robert Massoff, Samuel Jacobson, and other people, which is dark-adapted chromatic perimetry. And they demonstrated with this technique that there are different types of retinal experimenters, and they kept working on this for until now. So this is just to remind you of the distribution of rods and cones, which is different. So that's another argument for testing locally the response. So it's the same rationale as for the FST. You use blue and you use red, and making the comparison between the response to blue and response to red, you may estimate the contribution of cones and rods. So up to now, people who did this kind of study were using modifications of equipment. First, it modified the old Humphrey, then they modified even the Goldman, and more recently the Humphrey HFA2. But nowadays, this is no longer possible. It's no longer possible because manufacturers tend to limit the possibility to make any change, and that's because of the new regulations we have everywhere in the world. So having this kind of flexibility is no longer possible. This is showing an example of exam that was realized on the MonCvONE-CR. This is one of the standard tests performed by the staff of Professor Jacobson. We had they tried our equipment some months ago. And of course, this is going to take some time to test all these 76 points. But it's not mandatory to test all these points. You can make, we have the flexibility to implement tests with a limited number of tests. For example, 5 or 6 tests along the horizontal meridian or vertical meridian. I mean, we have all this flexibility inside the equipment.